Okay, we're going to learn about the Cartesian plane now. The Cartesian plane is the traditional XY axis that we're used to graphing on. We want to just make sure you have some terminology. Okay, the plane has an x-axis that tells horizontal distance and a y-axis that tells vertical distance. Positive is always either to the right or up. Okay, the point where they meet is called the origin. And these two lines divide the plane up into four pieces, which we call quadrants. Quadrant 1, 2, 3, and 4. Notice they go counterclockwise as opposed to clockwise. Now a point will be defined by its coordinates or its ordered pair, which is x comma y. X is always first. X tells the horizontal distance to get to that point, and y tells the vertical distance to get to that point. Now, we have two formulas that we are interested in for points on the plane. Okay, the first is, suppose you have 2 points and you want the distance between them. Okay, well, the distance between them would be the length of the line that connects them. And the easiest way for us to compute that distance is to draw horizontal and vertical lines that turn that into the hypotenuse of a right triangle. And the reason this makes it easier is because we happen to have something called the Pythagorean theorem, which is the most important theorem covered in this class, and we will come back to it over and over again, that says that a squared plus b squared equals c squared for a right triangle. C being the distance that we want. A is easy to compute because if you think about it, this point at the corner has the same x coordinate as the point up here and the same y coordinate as the point down there. And so A is just the difference between their x coordinates. And B is the difference between their y coordinates. Okay. This enables us to compute the distance formula, which is really just the Pythagorean theorem in disguise. So the distance between 2 points is the square root of x2 minus x1 squared plus y2 minus y1 squared. Here we see the a squared, the b squared, and of course, since we want c, we need to take a square root. Notice I don't need to put a plus or minus sign in front of this distance formula because distance is always the length of a line, and length can never be negative. So let's do an example. We have 2 points, negative 3, 5, and 3, 13, and I would like the distance between them. It does not matter which one you call the first point and which one you call the second point. So I want the square root of x minus x coordinate squared plus y minus y coordinate squared. 3 minus a negative 3 is 6. 6 squared gives me 36. 13 minus 5 is 8. 8 squared gives me 64. So I have the square root of 36 plus 64. 36 plus 64 is, of course, 100. And its square root is 10. So I get a distance of 10. Now the second formula we're interested in for points on the plane is called the midpoint. Imagine you have 2 points and you want to find the point exactly halfway in between them. Now, again, this is a formula that's disguising something else. How do we usually find a point halfway in between? We take an average. So the midpoint formula is literally averaging the x coordinates and the y coordinates of the 2 points. Be very careful that you're adding as in an average. People often make the mistake that they do subtraction, making it look like a slope instead of an average. Let's do an example with these 2 points. So the x coordinate of the midpoint will be I average the x coordinates and I average the y coordinates. So this gives me, well, 7 and 15 is 22. Divided by that 2 gives me an x coordinate of 11. Negative 3 and 5 is 2. Divided by that 2 gives me an x coordinate of 1. So now we know how to compute the distance and the midpoint between any points on the plane.